Hi and welcome to the review video for our upcoming test on Thursday. So in this test you will be tested over mole conversions. So this is going to be your moles to grams or your moles to molecules, and you can also have conversions from grams to molecules, and we'll go over how to do those in a second. And then you will also have percent composition, which we've been doing for the past couple of days. Along with that, in this video I'm also going to review how to write formulas for ionic and covalent compound, since it's a skill that we will be needing throughout the rest of this year. So on this test, we will have three different types of conversions. The first type of conversion you will be expected to know is from moles to molecules or molecules to moles. And the second type of conversion you will be expected to know is your moles to grams or grams to mole. And so when you're converting molecules to moles, you need 6.02 times 10 to the 23rd. We have learned this number as the Avogadro's number. And then when you go from moles to grams, what you need is the molar mass. Alright, so those are the two things you have to have. Now there will be some questions where you will be required to go from molecules to grams or grams to molecules. So I might give you the molecules and I might ask you to convert them to grams. But remember, you cannot do this directly. There is no conversion that will let you go from molecules directly to moles. Okay, so instead, what you need to do is go from molecules to moles and then moles to grams. You cannot go from molecules to grams directly. This will never happen. If you want to convert molecules to grams, you first have to go from molecules to grams, molecules to moles, and then moles to grams. Similarly, if you have grams, then you go from grams to moles and then moles to molecules. Alright, let's look at our first example, which is how many moles in 2.5 times 10 to the 25th number of molecules. So this is the number of molecules which is given, and you're expected to find moles. Remember what I told you in class? You will always underline the given and you will box the needed. Now that you have identified what's given and what's needed, you will set up your chart. So you set up a nice chart and you start with what's given. What's given is 2.5 times 10 to the 25th molecules. You take this molecule unit and you copy it down, and then molecules turn into moles. Now between moles and molecules, moles is bigger, so it gets the 1. So you put 1 mole, and 1 mole, as we all know, is equal to 6.02 times 10 to the 23rd molecules. Now that we have our chart set up, you need to divide these two numbers. So you're going to divide this 2.5 times 10 to the 25th number by 6.02 times 10 to the 23rd. Remember, we are going to ignore the exponents for a little bit and simply going to work with the non-exponent numbers. So let's go ahead and divide 2.5 over 6.02. So go ahead and figure out the answer. And the answer you should have gotten after rounding is 0.42. Now we're going to take our exponents, which was 25 and 23. But since we are dividing, we are going to subtract the exponents, and so this will become 10 to the second power. and we will rewrite this in scientific notation. So we're going to move this decimal one place to the right. So this becomes 4.2 times 10 to the first power, and that's how many moles you have, because molecule and molecule got cancelled, and so the only unit you're left with is moles, which is what was needed from this answer. Alright, so this is how the answer for this problem looks like. Second type of problems you might be asked is when you have the number of molecules given to you and you're being asked to find the number of moles. In which case, let's go ahead and start off by underlining what's given and box the needed. So what I'm going to do is I'm going to set this problem up for you, and I will leave it for you to solve, and if you want to check with me, then you can always come to class and clarify your answers. So you will start off with what's given. Of course, first you will make your chart. So after filling all the information, this is how your chart should look like, and then you're going to divide this and figure out whatever answer you get, and that will be your moles. Alright, let's move on to the next problem. Now example 3 is like what I told you in the beginning of this video, where you cannot go from one unit directly to another. So in this case, they gave you the grams of NaCl. That one's given, and the number of molecules is what you're looking to find. Now remember that molecules to grams conversion is impossible. Instead, what you need to do is you need to go to moles, and molecules will turn into moles, and then moles will turn into grams. On the other hand, if they give you something else, if they give you grams, then from grams you go to moles, and then from moles you go to molecules. In this example, you are going to go from grams to moles and then moles to molecules. So let's set up our chart. You start off with 20 grams of NaCl, which is what's given, and then you copy it down on the bottom. So you get grams of NaCl, and now you will change it to moles. But since moles is not what you're ultimately trying to find, you have to carry it down again. So you get moles on the bottom, and now moles will turn into molecules. Now all we gotta do is fill in the numbers. So 1 mole would be whatever molar mass of sodium chloride is, and then 1 mole is 6.02 times 10 to the 23rd. Now that we have set up our problem, you just need to do the math. So 20 times 1 times 6.02 times 10 to the 23rd. So when I set up all my numbers, I get 20 times 1 times 6.02, and then you notice that I used a different color for the exponent, and I did that on purpose because I want you to leave this exponent alone for a little bit until we do the rest of the calculation. So when I plug in all the numbers in the calculator except for the exponent, 2.06 is the answer I get, and then I simply take my exponent and I write it next to it. This answer is already in scientific notation, so I don't even need to move the decimal or anything like that. And so this is your final answer. So to sum up this problem, we went from grams to moles, and then we went from moles to molecules. I set up my chart because I had 2 conversions. I have 2 columns, and this is my final answer in scientific notation. In this next example, I've asked you to find the amount of lead nitrate in 3.1 times 10 to the 24 molecules of the chemical. Now you might be wondering where I got the formula from, and I'm going to review this, how to find the formulas when you know the names. in about a couple of minutes. So our process for this problem is going to look like you're going to convert the number of molecules, which is given in the problem, to number of moles, and then you will convert the number of moles finally to your grams, which is your final answer. So I start off my chart by using the given information, which is the number of molecules, and then I copy it down on the bottom, and then I convert it to moles, and then I copy down the moles on the bottom, and I convert it to grams. Next, I start filling the numbers in. So I know moles is bigger than molecules, so I put 1 for the moles. And I know that moles is bigger than grams, so I put 1 for the moles again. And I know that 1 mole is 6.02 times 10 to the 23rd. And then 1 mole would be equal to the molar mass of this chemical. Now that you've set up your chart, it's time to do the math. So you're going to write your numbers in. Notice that I wrote the exponents in a different color because I want you to remember that you are not going to put your exponents in the calculator yet. And the answer you get from the numbers without the exponents is 202.49. Now we will write in our exponents, and because you're dividing the exponents, you're dividing the numbers, so you will subtract the exponents. And so this becomes 10 to the first power. Now we have to rewrite this in scientific notation. So you have to move this decimal 2 places to the left. So this becomes 2.0249 times 10 to the third power. Remember, you moved to the left, so your exponent went up. And this is your final answer. You have 2.0249 times 10 to the third grams worth of lead nitrate when you have these many molecules of lead 3 nitrate. Now we're going to review a skill that I hope by now most of you have mastered. But I'm going to go over it one more time because this is absolutely necessary for you to be successful in the rest of the semester. So when you read this for chemical, it says iron 2 phosphite. Right off the bat, you know that this is an ionic compound. You know this because the first element is a metal, which means this is ionic. As soon as you figure this out, you are going to write the symbols of your elements. You know iron is Fe, and you also know that it has 2 positives, so you put 2 positives underneath it. How do you know it's 2 positives? Because of the Roman numeral 2. Now what about the second word? The second word is phosphite, and at this point you know it ends with ite, so anything that ends with ite or ate or us, you are going to refer to your polyatomic ion sheet. So if you take it out, you will I'm going to digress a little bit, and we're going to quickly review how to write formulas of polyatomic ions. So what I want you to do is look in that list and find the ion that has phosphorus in it or sounds something like phosphite. And what you will find is it is called PO4, and that it is called phosphate. Now you know that phosphate ends with 8, which means it is a base ion. Now if this is a base ion, what you have is phosphite. Now if you look at that list, I also told you that ite means 1 less oxygen atom. So PO4 becomes PO3. even though you change the number of oxygen, your oxidation number still stays the same. So if PO4 was 3 negative, PO3 is still 3 negative. Now that we've figured out that phosphite is PO3 with 3 negatives, all you need to do now is balance these charges out. Now I have less positives right now, so I need to add one more atom of Fe, but now I have more positives, so I need to add one more ion of phosphite, and then finally add more iron, and now I have a total of 6 positives here, and I have a total of 6 negatives here. The formula I would end up with is Fe3, because I have 3 atoms, and then I have to use parentheses because this is a polyatomic ion. Inside the parentheses I will write the formula of the polyatomic ion, and then because I have 2 of them, I will write the 2 at the bottom. The second example we have is called dinitrogen tetroxide. Right off the bat, you need to notice that the first element is a nonmetal, which means this must be covalent. As soon as you figure out that it is covalent, you know that you are going to use subscript. Okay, now let's look at our subscripts. Our subscripts are di, which we know is 2, and then tetra, which we know is 4. Now di goes with nitrogen, so you have N2, and then tetra goes with oxide, which comes from oxygen, and so you get 4, and that is your answer. So writing covalent compound formulas are very simple. You just need to know the subscripts and what number do they stand for. Here I have taken an example of another ionic compound, because this is a metal, so this is ionic. But this time I want you to pay attention to the suffix of the non-metal. You know that oxide, it ends with "ide." If it ends with "ide", then it's an element. It is not a polyatomic ion. And so in this case, all you need to do is write the symbols of the element. So barium is Ba, oxide is oxygen, and barium is 2 positive, and oxygen is 2 negative. So you have 2 positives and you have 2 negatives. They cancel each other out, and the formula you get is BaO. And so this is how you write formulas for ionic compounds that contain a metal and non-metal element. Alright, so this concludes your review for this upcoming test, and I hope you watch it multiple times and really do well on your upcoming test. So all the best.